Okay, let's get up and running. We want to install Visual Studio Code. That's where we're going to be writing all our code. Go to code.visualstudio.com or just simply Google Visual Studio Code and make sure it says Visual Studio Code in the top left corner, and then you want to download and install Visual Studio Code. I'm on Windows, so download for Windows, but they have a Mac version and a Linux version as well, so you can download it for your relevant OS. Once that's downloaded, run the installer and install that. And then let's go to Node.js.org next. And you want to install Node. Again, install it for your OS. I'm using Windows, so I'm downloading it and installing it for Windows x64. But under downloads, you can see they have a Mac OS installer and installers for Linux as well. So download and install Node.js. And once that is done, open Visual Studio Code. So once you've opened Visual Studio Code, let's go and view our terminal. So click View and Terminal, and we just want to double check that Node is installed successfully. So if we just do a node-v, this will tell us our Node version, and as long as you've got this version number or higher, you should be good to go for the rest of the course. Okay, let's get started. So let's open up VS Code, and the first thing we want to do is open the terminal. So if you click View and Terminal, then I advise you to go to a folder that you want to create your game in. So in my case, I tend to put things on my D drive in a folder called Web, and I'll go into a folder called Tutorials. If you don't know what folder you're in, you can always just type in pwd and that will tell you where you are. That's kind of handy. So when you're in the folder that you want to create your game in, you can type npx create React app and then the name of the game, and I'm going to call mine React Rogue. And then if you just hit enter, then that's probably going to take an age downloading stuff and creating the initial code. So I'll fast forward this and resume when that's all done. Now that will have created a folder called React Rogue, so we're going to change directory into that folder, cd React Rogue. And then we're going to open this folder up in Visual Studio Code. So you can do this from the command line doing code space -r space full stop and hit enter. And now we've got our React Rogue folder open here. And if we expand the source folder, we can see it's created a lot of files for us, and we're going to delete some of these files just to start with a slightly cleaner project. But before we do that, let's just check that this is working. So if we click on View and Terminal, and we'll type in npm start, which will start our React app. And that should have opened up a browser window that you can see your React app running in. If it doesn't, then just open up your favorite internet browser, i.e. Chrome or Firefox, and type in localhost :3000, and that should show your React app running. Now we can stop serving up our React app by just clicking back in the terminal and doing Control-C. And what we actually want to do is tidy up this folder a bit so we've got a little bit of a cleaner start. So I'll just pull this terminal down a bit here so we've got a bit more room. And let's see. So let's delete app.css. So just select app.css and press the delete key. Let's remove Let's remove our tests because we're bad people. So let's click on that and delete that. Let's delete that CSS file, index.css. So click on there, delete that. Let's delete the logo. Let's delete the surface worker because we're not going to worry about that. And then we'll need to go into index.js and remove any mention of index.css. So just select that line and hit delete. Remove the surface worker line. Select that and hit delete. Let's give ourselves a bit more space here so we can see it all. And then let's delete all the lines after the React DOM.render, and we can delete those as well. That should be enough, so do Control S to save. Click on app.js. We deleted the logo, so let's delete the logo line. We deleted the app.css, so let's delete that line. And we actually want to delete all the lines between inside the app div. So let's just select all those lines all the way down to there and hit delete. And then in here we can just type something like hello world, hit Control S. Let's do an npm start. Which will probably complain if we've forgotten anything, but it's not. So let's see if we get our hello world. And so we've got a nice clean hello world app with just a couple of JS files, which is great. It's a nice clean start for us to start working on our game. So let's go into app.js, and since this is a modern JavaScript tutorial, let's change this boring function app to something a little newer. So let's say const app is equal to, and the arrow function notation. If we save that, that will be quite happy. One of the advantages of the arrow function notation is that we can get rid of these curly brackets if we're just doing a one-liner, and we can get rid of the return. And hey presto, we have a single line component now. Now if we actually want to expand it to multiple lines, and we're just returning what looks like HTML but it's actually JSX, all we need to do is put brackets around here, and we can do something like, and if I save that, then that's multiple lines of JSX, and that is still completely happy. So the arrow function notation is just a little bit terser than the old way of doing things. There are some differences between arrow functions and standard functions, and we'll go through that in more detail in other videos. But we're going to be using this syntax a lot, so it's good to get used to it at this initial stage. So let's a quick overview of what this is doing. So the entry into our React app is actually this index.js file, and this is essentially saying render out the app component. So we're importing our app component and we're using it here using this notation, and we define a component in React using a function that returns some JSX, which looks like HTML. And so we've got an arrow function here that is simply returning JSX. And so we can go on to create our own components. So let's do that now. So we're going to create our main React Rogue component. So if we right click at the source folder and do new file, and let's just type in React Rogue.js. And the first thing you want to do to create a React component is you actually need React. So we import React from React. And then, just like we did in the app component, we just do const rogue is equal to an arrow function. And this is where we want to set up our canvas. So let's do that. So if we do canvas, and for the moment we'll have a hard coded in 256 width, 256 pixel width, and a height of 256 pixels. And because it's going to be a little bit difficult to see this canvas initially, because it's going to be white, we'll just style it with a border. And let's make the border just 1 pixel wide. And it's going to be a solid border, and it's going to be black. If we finish off our canvas like so, and then click save, it'll put it on multiple lines, hence we need these brackets here. And then don't do what I always do, which is forget to export our component. So we'll export React Rogue so that we can use it elsewhere. So where do we want to use it? Well, we want to use it in our very top level component app. So we need to import it. Just like if you go back to index.js, you can see that we imported app like that. We need to do the same in app. So we'll do import React Rogue from React Rogue. Now we can put JS on the end there, or we can leave it out. Doesn't matter either way. And then we need to use this component. So how do we use a component? Well, again, if you look back at index.js, you can see you just use this notation here. So let's do that. So we can delete this. So type in React Rogue like so. Control S to save. And let's just see if that's working. So if we look in our browser, we can see we have this canvas here with a border around it. And we can check that it's a canvas by right-clicking and doing inspect. And if we click on this arrow here and select it, hover over it, we can see that it's a canvas. It would be nice if we could specify the width and the height of the canvas as when we're actually creating this React Rogue component. Something similar to passing parameters to a function. Now the equivalent of parameters when it comes to React components is something called props. So what we can do here is we can specify that we want our width to be something along the lines of 40. Now here I'm specifying our width in tiles. So if we can think of the Rogue game space as being similar to a chessboard, then each square on a chessboard we can consider to be like a tile. And so we can say we want a width of 40 tiles and a height of 40 tiles. And then we want to specify the tile size, which I'm going to specify that to be 16 pixels. So these are props that we're passing into our component. And so we need to be able to handle this in our React Rogue component. So what we do is we simply say props here, and then instead of having a hard-coded value in here, we can say something along the lines of, we can say something like width is equal to props dot width multiplied by the tile size. And we can do a similar thing with the height. So we can say props dot height multiplied by the tile size. So if we save that and then run npm start, we can now see that our canvas size is now 640 by 640, plus the couple of extra pixels of our border. Now that's fine, but it gets a little bit annoying having to say props dot all the time. So what we can actually do is we can do something called destructuring. So what we can do is destructure our props object and pull out our width, height, and tile size properties. We have to put a brackets around here to make this valid. And now, as you can see, we don't need our props anymore. So that makes everything look a little bit tidier. Now we actually want to change this from what they call a concise body, which means that we just need these brackets and it's one single expression that is getting returned. So you can use concise body if it's just a single expression. But if you want to do something a little bit more involved, we need to switch to a block body. So if we put in curly brackets here, and then what we actually need to do now is return our JSX like so. If I just do save, Prettier will tidy that up for me. And so now we can actually start adding in other statements since we are now using a block body. So what's going to be handy later on is getting a reference to our canvas. So we can use a hook for this. So this is our first hook, and we're going to call it canvas ref, and we can do react.use ref, and use ref is the actual hook, and what we do is we pass it an initial value. And actually you can leave this out, you can specify null, but if you just do that, it will actually default to null. And so it's not very useful that being null. So how do we actually link that to our canvas? Well, we can say something like ref is equal to canvas ref. And now we have a handy reference to our canvas. And we can always get to our canvas by canvas ref.current. This might be a good time to introduce you to our next hook, which is use effect. So we can get easier access to these hooks by destructuring them out of the React module. So we can say use ref and use effect, and then we can get rid of that React dot there. Now with use effect, we actually it's different from the use ref in that we actually supply it a function. So as per usual, we're going to use a arrow function, and for the moment let's just write out to the console.log, and this is where we're going to actually draw to our canvas. So what is this use effect hook? Well, essentially it's a lifecycle hook, and it gets called whenever the DOM gets changed. And so it is the perfect place to actually update our canvas when we've actually changed the state of our game. This will become clearer as we progress through the course. And I will do a separate section explaining these concepts in more detail. So if I save that and go back to our React app, and if I right click and inspect, then go to console, you can see that we've got draw to canvas here. The arrow function that we're passing into useEffect is getting called after our DOM has initially been rendered. So as I said, this is where we're going to draw to our canvas. So of course we need a reference to our canvas so that we can draw to it, and we draw to it using something called a context. We'll shorten that to CTX. And like I said earlier, we get to our canvas via the canvas ref dot current. So that's going to pass us back our canvas, and then we want to get the context of the canvas, which is get context, and we want the 2D context. Now we can draw directly to our canvas using clearRect, and so we want to clear the whole canvas. So we'll start at 0, 0. We know the width of our canvas, it's width times tile size, and our height is height multiplied by tile size. So that will clear our canvas. It actually writes out transparent black to every pixel. That clears the canvas nicely. And since clearing it won't do anything visible, let's do something that we can actually see. So if we set the fill style to black, and then we can do fill rect, and let's just write out a 16 by 16 square just somewhere on the screen. 16 by 16. So we'll save that, and let's go back to our React app, and as you can see we have a black square on our screen. Very exciting. Okay, this video is going to be way more exciting because we're going to get our black square to move around. So that's pretty cool. So let's do that now. We're going to create an input manager to, funnily enough, handle input. So we're going to make a class. Going to call it input manager. And we're actually going to implement what's called the observer pattern. It's a super cool pattern, really handy for event management. And I'll kind of explain it as we use it. So I'll just write the code, and then we'll start using it, and it will start to make sense, I think. So we're going to be able to subscribe to our input manager, and what we mean by that is we're going to pass it a function, and the input manager is going to essentially call that function depending on what inputs it receives. The functions that subscribe to the input manager will be called whenever the input manager handles an input. So we want to be able to subscribe. We're probably only going to actually subscribe to the input manager with one function, but the observer pattern actually enables multiple clients, if you like, to subscribe to it. So we essentially keep a list of functions that are subscribed to the input manager. So we also want to be able to unsubscribe. And essentially we replace the observers list with a list that filters out the function that we're trying to unsubscribe. Just widen this a bit if we can. So we can subscribe and we can unsubscribe. Now we actually want to handle calling all the functions that have subscribed to us. And we're going to call all these functions, well, like I say, in our case it's probably going to be just the one, with action and data. So we're just going to go through our list of functions and call them all. With the action and data parameters that we're passing in. Now we want a function that handles input. We're going to keep it pretty simple. So this method will actually receive an event object, and what we tend to do is call prevent default on the event object because we're handling it ourselves, and then we do a big switch statement, and the event object has something called a key code on it, which we can tell which key is being pressed. So key code 37 is the left arrow key. So when the left arrow key is pressed, what do we want to do? Well, we want to call any function that's subscribed to us. We want to say, right, the action is move, so we want to move somewhere. And the data is essentially a vector saying which direction we want to move in. So -1, x being -1 and y equals 0 is moving left. It's important to break after each case statement. So let's do 38, which is up. So let's just copy that because I'm lazy. We'll paste this in, and up is -1 for the y. And remember to do a break. In fact, let's just copy both of those. Case 39. What's case 39? That is right. So x is 1, y equals 0. And 40 is down, so we're not moving on the x. And we want to move 1 on the y. And then just to make this switch statement happy, we should put in a default, which we'll just break on. So how do we actually handle keys? Well, where does that actually get called from? Well, we need to add an event listener to our document. So we can create a method called bind keys, which is going to set this up. and we can say something like document.add event listener, and we're looking out for the key down event, and we're going to call handle keys. And we also want to be able to unbind this to remove the event listener. So unbind keys, and in that case you want to remove the event listener with exactly the same parameters. So that's our input manager done. So we want to set that up in our React Rogue component. So we can set that up here. So let's do let input manager equal new input manager. That's how you create an instance of a class, hence an object. And it's complaining because we haven't imported it, so let's import it. Did we remember to export the input manager? Of course we didn't, so let's do that. Export default. Told you I always forget to do that. So the question is, where do we want to subscribe to input manager and call bind keys, so we start listening for events on the document? Well, again, we can use the use effect hook, but to keep things neat, you can simply actually just call it again with another method, which is kind of cool. And the nice thing about that is it just keeps your logic a little bit cleaner, because I can just say, well, now here I'm sort of binding my input manager. So input manager, and we want to start listening to events on the document, and we want to subscribe to our input manager. And what do we want to subscribe with? Well, like I said, we subscribe with a function. So we haven't written the function yet, but I'm going to just call it handle input. So we haven't got that yet. So that's a to-do. But we also want to be able to unsubscribe when, say, this page is closed. When we close our app. So how do we do that? Well, use effect, actually, you can return a function, and this function gets called when this component closes. That's the perfect time to unbind our keys, and also unsubscribe, again with this mythical handle input, which we haven't done yet. So let's do handle input now. So we can do this up here, and we can say const handle input, and if you remember rightly, we're going to receive an action and some data from input manager. And for the moment, let's just console log out so we can see if this is actually working. So we'll use this backtick notation, which means that we can do something like action, data, missing my arrow function here, so that makes a bit more sense. But data we know is an object, so if you want to be able to see that, we have to do some JSON stringifying. Which just means that we can have a look at that data, data object, and see a string rendition of it. So let's see if that works. If we do an npm start, first of all, see if it actually compiles. So we're getting an error here. This observers for each. Let's see what that's all about. Line 12. Yeah, calling it observer here and observers elsewhere. Yeah, and there. Subscribe. Yeah, okay. I think I've got them all. Yeah, great. So let's inspect console log. So that's right, which x equals 1, left should be -1, yep. Up should be y being -1, and down should be y1. So that's great. And as you can see, bind input, draw to canvas. So both of our functions are being called here. So now we actually want to, as I promised, didn't I? I promised that we would move the black square around. So let's do that. So we actually want to say we've got something called player, which is what we're trying to move around the screen. We're trying to move the player around the screen. And for the moment, it's a black square. So we use something. This is the first time that we're messing around with state now. So we use the use state hook for state. So let's bring it in here. Use state. And what we do is we supply use state with an initial value. So for our state, so for the moment we're just going to say the player has an X, and we'll set that to say 64, and a Y, and we'll say 128, just some random values. So what does use state give us? Well, it passes back our player state, initialized to these values here, and it also passes back a method that we can use for updating the player. So it's important to remember that you don't change the player directly. You always change the player via the setPlayer method. That's the rules. Okay, so how do we do that? Well, what we're going to do is we're going to create a new player which is a copy of the player. Now, how do you do a shallow copy? Well, there's a cool thing in modern JavaScript called the spread operator, and we can just do ... player, and that just pulls all the properties out of player and sticks them in new player. So that's super cool. So that's copied player, because we can't, like I say, we can't change player, we're not allowed to change player, but we can change new player now because it's a copy. So we can say new player dot x, and what do we want to change new player to? Well, when we move, we want to move by the size of the square or the tile. We know that the tile size is the size of the tile. But we want to multiply that by our x and y that we're getting back from data, this data here. Like I say, that's like a vector saying which direction we want to go in. So we do data.x multiplied by tile size and new player y, data y multiplied by tile size, and then we use the set player function. Like I say, that's what we use to update player, and we just give it new player because that's got our changes in. Well, we may be updating our player, but we aren't actually rendering our position of our player yet. So we need to fix that. So we're drawing to our canvas down here, and at the moment we're just hardwiring the x and y of our tile, and now this wants to equal player.x and player.y. Simple as that. So let's see if that works. So we've got our black square moving around quite happily. You can go off the screen, but we're not worry about that at the moment. So that's a little bit more exciting than a static black square, but we've still got a little bit of ways to go before it starts to look more like a game. But we'll leave that for the next video. So at the moment our player is quite simple. He's just got an x and a y, but he's going to get a little bit more complex than that. We're going to want to have a health on the player, and then this is a little bit messy, that we're kind of moving the player around within this React Rogue component. It'd be quite nice if we had a player class that handled this and also handled drawing itself. So it'd be kind of good if we could just do player draw, and the player knows how to draw itself. So let's do that now. So if we right click on new and right click on source and choose new file, and we want a player.js file, and this is simply a player class, and we're gonna have a constructor that takes an x, a y, and a size. Now this x and y will actually be our grid coordinates, so that's something to bear in mind. Let's assign these to some properties, like so. And the first thing we want to do is handle moving. Going to be passing in essentially the vector. So we want to, like I say, x and y is actually now the tile coordinates. So we are just going to be incrementing or decrementing them by 1 on each movement, i.e. not multiplying by the size. And then, like I said, we want to be able to draw the player from within the class. So we can pass in the context, that's fine. And for the moment we'll hardwire in the color. Let's make it red, just for giggles. And we want to actually set the baseline here, the text baseline, to hanging. Otherwise it appears above the tile when we want it to be inside the tile. So that, like that. And we want to specify a font. So I'm going to go with Helvetica. And then we're not going to draw a square, black square this time. We want our player to be a proper rogue-like character, which is the @ symbol, if you know your roguelikes. And like I say, this X and Y are the tile coordinates, so we need to multiply them by size to get the actual pixel coordinates. And there you go. And let's not forget to export. So we have a player object now, so how do we use this? Well, let's go back to React Rogue. And we don't want to do this anymore because we're a little bit more advanced than that now. We actually want to initialize with player. Let's just for the moment set it to, I don't know, 1, 2, and we're passing in the tile size because that's the size of our tile. And we won't worry about moving quite yet. Let's do the render now. So now we have a draw method on the player, so we can delete these 2 lines and just do player.draw, and if you remember, we're passing in the context. Let's just see if that works. We've now got our @ symbol instead of our rectangle, but moving doesn't work, actually dies, so let's sort out the moving now. Now, unfortunately, the spread operator is not going to cut it anymore. What we actually want to do is create a new player. So a totally new player object. Let's delete these 2 lines. This is still good, but what we want to do is we need to do an object assign. And we want to copy over the properties from player to our new player. And then once we've done that, remember we never change the original player. We've got to change the new player, and we move the new player using data X and data Y. And if I'm not mistaken, that should be enough to get that working. Excellent. So we now have our @ symbol moving around. Okay, so our guy is wandering around our game space, but he's looking a little bit lonely. He's wandering around in a void. So we need to fix that. We want him to wander around in a world. So let's do that. So right click on source, new file, and we're going to call this world.js. and we'll create a class as per normal. We will call this world, and we'll create a constructor, and we'll take a width and a height of the world and a tile size. And so let's assign these to properties. So we have a width property, a height property, and a tile size property. And so we want this world to be a two-dimensional world. So we can describe it with a two-dimensional array. So we create two-dimensional arrays in JavaScript by creating, first of all, a one-dimensional array. So this will be our width. So if you think about it, a two-dimensional array is just an array of arrays. So let's go through our one-dimensional array. And on each element of the array, we'll create another array, which is the height. So our map's going to be fairly simple. It's just going to consist of either a wall or not a wall. So if you put a 0 in one of the elements of the 2D array, that means that it's an open space, and if we put a 1 in this array, then that is where we're going to place a wall. So let's do that very simply to start with, just to see this working. So we can do a very basic random map. So we'll just randomly create walls and spaces. So at least we'll then see something actually happening, and it's pretty easy to do this. So we'll create our random map method, and we will just say and this line here just puts randomly either a 0 or a 1 at each element of the array. So just like our player, we want our map to be able to draw itself. So this is going to be very similar to the draw method of the player. So we pass it in a context, and just to save time, let's just copy this here because we're doing something pretty similar, but instead of setting that element, we're testing that element, and we're saying, okay, if this is a 1, we'll create a wall, and if it's a 0, we won't do anything. So we want to draw a wall, and pass in a context to this draw wall method, and where we want to place the wall, which is the XY from the array. So our walls are going to be black for the moment, and they're going to be black rectangles, and we're getting the X and Y, but they're in tile coordinates, so we have to times that by the size of our tiles. And how big are these rectangles? Well, they're the size of our tile. Now let's not forget to export this so we can use it elsewhere. And so to quickly go through this, we're creating a two-dimensional array here in our constructor. and then we're calling this create random map. What does create random map do? Well, it randomly puts a 1 or a 0 in each element of the two-dimensional array. Our drawer is then going through that array and saying, well, if there's a 1, and there's a random chance of being a 1 because of this create random map, then we'll draw a wall. If it's a 0, it won't do anything, so we'll just keep it blank. And that's about it. So let's use this in React Rogue. So first of all, we need to import it. So we'll import our world from world. And where do we want to draw our world? We want to draw our world just before we draw our player. So we can draw it down here. But we haven't defined our world yet. So we can define our world here. And we know at some point that we're going to want to change things in our world. So we want to be able to change the state of the world. So how do we change state? Well, we use the useState method. And as you can see, this is very similar to setting up our player. Now we're not setting our world at the moment, that's why that's kind of underlined, but we won't worry about that at the moment. We know that this is getting called anyway. So that's not a problem at the moment. So let's actually see if this works. So let's do an npm start. And as you can see, we now have a map that our player can walk around in. But of course there's quite a few things wrong with this. We can walk through walls. The map is not really very traversable. It looks pretty horrible because it's just a random set of walls and spaces. So let's fix that now. So if we go back to world.js, and we don't want to create a random map, we actually want to create something that looks like a proper dungeon. Now there's a very cool JavaScript library that can help us out with this called Roguelike. So if I just come down into our terminal and we type npm install Roguelike, enter. So now if we go up here and we can import map from Roguelike, like so. And so we can replace this random map with create cellular map. And so let's overwrite that. And so this create cellular map is going to use a cellular map generator from Roguelike. So map.cellular, and we pass it in a width. We pass it in a height. we pass it in some parameters, and the only one we're really interested in is we want to say that all our rooms should be connectable, i.e. we can get from one room to another, or one cave to another. Now we want to seed the map with some random values. That's just how this works. I'm not going to go into too many details about how this works, but you can definitely dig into cellular map generation. It's actually not that too difficult to understand, and it's quite fascinating. Just you know, what kind of different map generation algorithms are out there. There's lots of different types. But this cellular algorithm actually produces some pretty cool results. So this callback here is just making sure that we want to make sure there's walls all around the edges of our map. So that this just facilitates that. So you might not have seen this before. It's actually a kind of one-line if statement. Might be a little bit clearer if I put brackets around here. And this is saying, if this is true, do this, otherwise do this. So if this is true, assign 1 to world map XY, otherwise world map XY should equal 0. So then we want to call map.create with our callback, and then map.connect again with our callback, and our empty spaces are actually considered 1. You remember here, if 0 is a wall, so 1 is actually our empty space. So that's why we have to pass in 1 there. So let's see how that's looking. And as you can see, we now have a nice little dungeon, and we should be able to get from one side of the map to the other, because all our cave systems should be connected. Like so.